Today I'm going to explain what exactly is the binomial theorem. And this binomial theorem is what you'll be frequently encountering. It's part of the topics of the junior college JC2 level, A levels exam. And this binomial theorem is very important because it's used in many types of daily application. For example, let's say if you want to predict, binomial theorem is basically used for prediction. So if you want to make predictions of how certain things are going to function, for example, in finance, how is it going to function in the future, then you will have to use binomial theorem in order to model the different possibility. So it's going to be more than just whether or not it is going to happen. The case is, by using binomial theorem, is that the scenario is going to happen, but how many scenarios are there? How many possibilities are there? So you are going to use binomial theorem in order to simulate all the different kinds of possibility. So binomial theorem is being used in computing, for example, in order to simulate outcomes in finance, to simulate outcomes in weather, and to simulate outcomes in disasters, and many other different kinds of things. And why is it called binomial theorem? Because bi means that there's two elements to it. Then nomial is the element, all right? So there is also, in the future, when you go to university, there is also multinomial theorem. So now you focus on this binomial theorem. So what is binomial theorem? Like what I said, bracket plus b, a plus b. So this is an example of a binomial theorem. A plus b, binomial, two elements, a plus b. Okay, so that's a and b, so it's binomial theorem. So a very important part of binomial theorem is to be able to, from first principle, calculate how are you going to expand this particular equation to the binomial series. All right, so before we can begin, so there are different ways of calculating the binomial expansion. So many students, they try to use calculators, they try to use computers in order to calculate this binomial theorem. But what if your calculator run out of battery? So you must be able, from first principle, to calculate the binomial theorem expansion at any point of time. So before we go into binomial theorem, I would like to introduce to you something called the Pascal triangle. So what is the Pascal triangle? The Pascal triangle is basically a type of mathematical series that helps you to predict the numbers that you'll be using for your binomial theorem. So for example, let's say the Pascal triangle goes in this way. All right? So I'm going to expand it in a pyramid fashion, and I'm going to show you how this Pascal triangle is going to expand. And by knowing how to expand the Pascal triangle, you will be able to replicate the outcome readily anytime, and you can replicate this in your exams, in your tests, or without calculator in your programming, and use this outcome to double check with your binomial expansion series. So now we have 1. So what I've done is that I expanded to, after 1, right, this is the first row, 1. Then I expanded to the second row, 1, 2, 1. Okay, so this is the second row. Now I'm going to expand to the third row. So what is the third row? I'm similarly going to write 1. Then remember this, how I'm going to calculate the third series. 1 plus 2 is equals to 3. All right. Then after that, 2 plus 1 is also equals to 3. Then after that is 1. All right. So this is the expansion for the third row. Now I'm going to go for expansion in the fourth row. Expansion in the fourth row goes like this. 3 plus 1 equals to 4. 3 plus 3 equals to 6. Then 3 plus 1 equals to 4. 3 plus 1 equals to 4. Then you end with a 1. So the fourth row expansion is 1, 4, 6, 4, 1. Now we're going to expand to the fifth row. So by expanding the fifth row, we're going to use the same formula to calculate the fifth row, which is, okay, 1 plus 4 equals to 5. Then 6 plus 4 equals to 10, followed by 6 plus 4 equals to 10. Then 4 plus 1 equals to 5, followed by 1. So this is the fifth row expansion. 1, 5, 10, 10, 5, 1. Now we're going to the sixth row. 1, 6, 1 plus 5 equals 6. 5 plus 10 equals 15. 10 plus 10 equals 20. 10 plus 5 equals 15. 5 plus 1 equals 6, followed by 1. So this is basically the Pascal triangle to expanding the number series that you will be used for generating the coefficient of a binomial expansion set. And it's very important because once you know how to generate this Pascal circle, you can basically predict the future outcomes. And the more you can generate, the more outcomes you can predict. And this means that you are going to predict your future outcomes with even more accuracy. And this is very important because once you understand this, to finding the coefficient, you understand how to generate your binomial series. Then from there, you can code all this into your programming. So therefore, when the system feeds certain information into your A and B, what I've stated, right, it will, according to the binomial series, generate the outcome and show instantly on your computer screen, informing you of what is going to happen in the future instantaneously. So this is very important for finance, health, genetics, weather, disaster, so on. So this is a very important thing. And later, I will teach you how to make use of this Pascal triangle in order to double check, in order to generate your binomial expansion series. Now let's go on to another important theory, another important equation. Okay. So now let's try to do a simple expansion of a binomial theory. Let's say, for example, we have x plus y to the power of 2. Okay? x plus y to the power of 2. So normally how you will expand is being expanded like this. Equals to x plus y bracket, then bracket x plus y. Okay, x plus y to the power of 2 equals to x plus y multiplied by x plus y, right? And then if we have x plus y to the power of 3, so how do we expand this? Same, we will have x plus y bracket again, x plus y bracket x plus y. So now, because to the power of 3, we have 3 sets of x plus y. So this is normally how you expand the series, but this is not the binomial expansion. This is not how you expand for binomial series expansion. So let's say if we were to solve for this, right? Okay. So will be, you take the x multiplied by the x over here. So this becomes x squared. Then you take the x multiplied by the y. Okay, so it's plus xy. Then you take y multiplied by the x. What it equals to is xy. Then the last term is y multiplied by y. So you get y squared. So that's not the end of it. So the simplified form is x squared plus 2xy plus y to the power of 2. So this is how you will perform expansion for this x plus y to the power of 2. This is one way of expanding for series, for equations that are to the power of 2. And if you were to expand to the power of 3, let me just demonstrate to you how it is being done. Let's say it's being expanded to the power of 3. So now we have x plus y to the power of 3, which is equals to x plus y bracket x plus y x plus y. Okay, so now we have expanded to 3 terms. So how we are going to solve for this non-binomial series solving, all right? But somehow or rather it is related, but you still need to know from first principle how are you going to solve this. Then you're going to learn how are you going to use the binomial theorem to solve for the rest, all right? So this is x plus y expanded into 3 terms. So let's calculate the first one. So what you do is you focus on the first 2 elements, all right? So what's happening is that is x squared plus xy plus xy plus y squared. This is the same as what we have calculated for x plus y to the power of 2. So now you're going to replicate the same outcome. Okay, then, so what you have multiplied, right, is like this. For the first 2 terms, the last term remains untouched, so leave it as x plus y. Then, now, we have to make it simpler, right? So x plus x to the power of 2, 2xy plus y squared. Now we have this form. Alright, so now you have to multiply this bracket, this term against this term. So what is going to happen is you take x squared multiplied by x is equals to x3. Okay, 2xy multiplied by x is equals to 2x to the power of 2y. Then you have you have y to the power of 2. So multiplied by x is equals to xy squared. Now next we're going to multiply the y term. Then we have x squared y plus x squared y. Then next is 2xy multiplied by y. So what you get is 2xy multiplied by y, and that will equal to 2xy squared. The last term is y squared multiplied by y. So what you get is y to the power of cube, right? So this is how you do it. First, you multiply the first 2 segments, you get the outcome, and use the outcome to multiply the last segment. So this is how you expand. So what you get is x cubed plus 2x squared y plus xy squared, then x squared y plus 2xy squared plus y3. So this is one way. It's not simplified yet, but roughly this is how you would do, or how you do the expansion without the binomial series, using the binomial technique. So now you roughly know how to do this, right? So this is one way of expanding the binomial, expanding this equation without using the binomial series, but from the first principle. So it means that even if you forget how to generate, forget about the binomial theorem, right? you can still expand this equation using your techniques from the first principle. All right, now I'm going to show you how to expand this particular equation using the Pascal triangle. Okay, so now you remember the Pascal triangle. What we did was that we had a certain order. Which is the Pascal triangle. So the Pascal triangle is being done in this way. All right, 1, 1, 2, 1. You may not be able to see it, but I'll just write it here for reference. Okay, maybe I'll just write it as large as possible. 1, 3, 3, 1, 1, 4, 6, 4, 1. Then it's 1, 5, 10, 10, 5, 1. Followed by 1, 6, 15, 20, 15, 6, 1. Okay, so this is the Pascal triangle. It's shaped like a pyramid eventually. And remember, this helps you to predict the future. It helps you to generate the outcomes, the future scenarios, so that you better understand how the future is going to be like. And it's going to be used in many applications such as finance, disaster, weather, and so on, just by referring to this pyramid shaped thing. All right. So now, let's say just now we had binomial expansion x plus y to the power of 2 to the power of 3. So what if I want to do an expansion to the power of 6? So this is where I can make use of the Pascal triangle in order to generate an expansion up to the power of 6. So now if you look at this, so the first row is if you were to generate to the power, okay, let's say if you want to use the binomial theorem in order to expand a particular binomial equation, so what you have to do is, if you are generating an expansion to the power of 1 scenario, therefore you use this 1. But if you are generating to the power of 2, then you will refer to the second row and it's denoted by 2. Then if you want to generate for the third row, then you go for the third row, which is denoted by the 3 here. Then eventually, if you want to generate to the 6th row, then you look at 6. So therefore, the coefficient to be used in the binomial series are all here. It's 1, 6, 15, 20, 15, 6, 1. So you will, if you are generating to the power of 6, you will be using the coefficient that are being stated on the 6th row, which is exactly the numbers that I've read out to you. Okay, 1, 6, 15, 20, 15, 6, and 1. So for example, let's say we have x plus y to the power of 6. All right. So by using the Pascal circle, by using the Pascal triangle, you will be able to generate the expansion x plus y to the power of 6. So this will be equals to, remember, okay, the first term for the binomial series is, the first term is always x, all right? Then the second term, the last term of the series, will always be y. So the first term will be 1 x to the power of 6 y to the power of 0. Remember how I write it, okay? So basically, why do I put a 1x? It's because 1x is actually equals to x. So after expanding the entire binomial series, what you have to do is take away the 1, because 1x is basically x. But you see, this is 1. Therefore, the first term is 1, then x to the power of 6, then y to the power of 0. All right? The next term for the binomial series, okay, refer to this. The coefficient is 6. So what you have to do is you write 6 x, y, and this time round, 6 will be reduced to 5. And y will increase by, the power of y will increase to 1. The power of 6 will reduce to 5. All right? So 5, 1. So what's the next term? The next term, the coefficient for the next term is 15. So what you have to do is you write 15, then xy. So now the power of x will be further reduced from 5 to 4. On the other hand, the power of y will increase from 1 to 2. Okay? So this is 4, x to the power of 4, y to the power of 2. Now we are generating the next term, and the coefficient for the next term, by referring to the Pascal circle, it means that the next coefficient will be 20. Okay? So it's 20. Same, write xy. Then now the power of x will be reduced to 3. And the power of y will increase to 3. Okay? Remember that the power will always equals to 6. And this is how you check the terms. So 6 plus 0 equals 6. 5 plus 1 equals 6. 4 plus 2 equals 6. 3 plus 3 equals 6. It will always equal to the power coefficient. Now we're generating the next term. The next term is 15. According to the Pascal circle, it's 15. So you write 15. Now write xy. Remember xy can be anything. It can be replaced by anything. It gets more and more complicated. But the main thing is, from first principle, it is xy. As long as you know that it is xy, you can tackle this with confidence. Now this time round, the power of x will be reduced from 3 to 2. Whereas the power of y will be increased from 3 to 4. And now we are generating the next binomial term, and that is, the coefficient is 6. So you write 6 xy. So the power of x will reduce from 2 to 1. And the power of y will increase from 4 to 5. Now we have come to the last term, which is why we're coming back to the 1. Okay, plus 1 xy. The power of x will reduce from 1 to 0. And the power of y will increase from 5 to 6. So how are we going to rearrange this to simplify it further? Okay, now let's look at the first and the last term. And this is how we're going to simplify it. So we take away. So basically what it means is that the entire outcome, the final outcome will be 1x to the power of 6 to the power 1 times x to the power of 6 multiplied by y to the power of 0. So what this means is that you take away 1 and you take away, because y to the power of 0 is always equals to 1. So you take it away as well. So the first term is actually x to the power of 6. Then the second term will be, just copy accordingly, 6x to the power of 5 multiplied by y, because y to the power 1 is equals to y. Then you take 15, the next term over here, 15 multiplied by x to the power of 4 multiplied by y to the power of 2 multiplied by 20 to the power of 3 y to the power of 3, then plus 15 x to the power of 2 and y to the power of 4, then plus 6x. 6 multiplied by x to the power 1. X to the power 1 is equals to 1. So therefore you continue to write x to the power 1 is equals to x. Therefore you just continue to write x. Then 6 to the power 1 multiplied by y to the power of 5. Okay, now the last term of the binomial expansion is 1 multiplied by y multiply x to the power of 0, then multiply y to the power of 6. So what's happening right here is you take away the 1, and for x to the power of 0 is equals to 1. Therefore, it's 1 times y to the power of 6. Therefore, the last term is y to the power of 6. And therefore, this is the final term for the binomial series. And this method of calculating the binomial series is being done by using the Pascal triangle. And if you have a chart, a very large chart of the Pascal triangle, you basically can refer to the huge pyramid chart in order to generate very complicated outcomes that can help you to foresee very far and very complicated scenarios of the future, of any outcomes in the future.
Tuition Near Me, your #1 portal for everything that is related to education. See you at Tuition Near Me.